Examples of Newton's laws. First example. So in this example, we need to calculate the acceleration of a 10 kilogram block that experiences an applied force of 20 newtons and a friction of 5 newtons. The first thing we should always do is do a free body diagram. So our free body diagram for this, we have our 10 kilogram block that experiences a force of 20 newtons to the right and 5 newtons to the left. Because this is going in the opposite direction to the 20 newton, we can make that a negative 5, showing the direction. Okay, so the first thing we can do then is find out the net force acting on the object. So F net is equal to force applied plus the frictional force. So we can substitute in our values there, 20 plus minus 5, once again because that is acting in the opposite direction to the 20 newton. F net. That means that we have a total net force equal to 15 newtons. We can then find out the acceleration by using Newton 2, because we know that F net is equal to mass times acceleration. We have our F net of 15, we have our mass of 10, and then can work out what A is. And so that means we'll get 15 divided by 10, or 1.5 meters per second squared. Now this is all good and well to do it in two equations, but I suggest, because things are going to get a little bit more complicated later on, to do this in one go. We can basically do that by just writing out Newton's 2. So F net is equal to mass acceleration. Now, F net can be broken down to show us that. And so we can then have the force applied plus the force due to friction is equal to mass acceleration, which means that we then get 20 minus 5 is equal to mass acceleration, and we get to exactly the same thing as we did previously, just we used one equation, which just makes it neater in your books or exams and simpler to do. Example 2. Now in this case we have two blocks, a 3 kilogram and 1 kilogram block. They are connected by a string. An 8 Newton force is applied to the 3 kilogram object, and then we need to determine the acceleration of the blocks and tension in the string. Okay, now there are two things that we need to find out. Firstly, what is the acceleration? And secondly, what is our tension force equal to? So firstly, let's do acceleration. Right, now acceleration, let's do Newton 2 for both of these. Before we do that though, we should always do the free body diagrams. So the free body diagram for object A, there is no friction, and so the only force acting on it is our tension force. And so we have our tension force. It's acting to the right, so it is a positive tension force. Then on B, we have two forces acting. We have our applied force, which acting to the right, so we know it's going to be positive, and we have a tension force, pulling to the left, which will then be a negative. Now, because of Newton 3, stating that if object A exerts force on object B will exert an equal and opposite force on object A, that tells us that these two tension forces are going to be equal, or it is technically the same force. All right, so let's get back to acceleration. Now, we first do our Newton 2 calculations. So this is going to be F net on object A is equal to mass acceleration, and our F net on object B is equal to mass of object B times its acceleration. Okay, so let's put in the values that we do know. F net of A. The tension force is the only force acting on object A. Therefore, Ft is the net force. We also have our mass of A, which is 1 kilogram, times the acceleration. We can see now that we have two terms that we don't know and so can't solve this yet. Then, the forces on object B. So we have our tension force and our force being applied. And so force applied plus the negative force due to tension is equal to the mass of the object, A. Now we do know that our force here is 8 and our mass is 3, just to correct that, minus our tension force is equal to 3A. Now, in both of these, we don't have that second term. And so what we have to do is solve this simultaneously. Obviously, we're trying to solve for acceleration, and so we need to get rid of Ft. Because we know that Ft is equal to 1A, we can substitute that in for Ft. And so we get 8 minus Ft is equal to 3A. We can substitute in that value, giving us 8 minus 1A, so we can just put A in there, is equal to 3A. And solve this, that means that's going to move over to that side, giving us 4A, 8. And that in total then means that A is going to be equal to 8 over 4, or 2 meters per second squared. The next part of the question asks us to calculate tension, or what Ft was. Okay, so we have both these formulas. To find out what tension is for the first, or for object A, we can use that formula that the tension force is equal to 1 times acceleration. Because we now know that acceleration is equal to 2, that tells us that the tension force is equal to 2 newtons. Just the same, we can then use that formula where we have 8 minus Ft is equal to 3A. Our 8 is obviously the force being applied, and so we've got 8 minus Ft is equal to 3, and now we know our acceleration is 2. So that gives us 6 minus 8 is equal to our negative tension force, which then means we've got -2 negative tension, which means our total tension force there is 2 newtons. Now, the problem is we can see that both of these are positive values. And so this is where that whole vector idea comes in. And so we should then say this is 2 newtons to the right, and this is 2 newtons to the left. And then, just as a little side note, that whole thing there is slightly pointless in this case because there isn't any friction. And so what we could have done instead of all of that is then say, let's look at the total forces acting here. Because this is a Newton 3 force, we know that that negative force is equal to that positive force. Therefore, those two, when we put them together, are going to be equal to 0. That means we can look at the total net force on both is equal to the mass of A plus the mass of B times acceleration, which that means we can just have 8 is equal to 1 plus 3a, which gives us 8, 4a, which means a is equal to 2 meters per second squared.